Hello everyone and welcome back to the channel. In this video we're going to cover the topic of subnetting. Now I know this might be a daunting subject for most people just entering the network field, and it's also one of those things that is key in knowing if you ever want to land yourself in a job position as a network engineer or a network administrator. So I'm here to make this video to make this as easy to understand as possible, and I think what I'm going to do is break this up into three different videos, and we're going to start with, in this video, subnetting based on the number of hosts. So if you have a host requirement per network, the next video is going to be subnetting based on the number of networks. So if you have a network requirement. And the third video is going to be finding the network boundaries. Basically what that means is if say you have a network and it has a non-classful or a classless subnet mask. So say like a /18. In that video I'm going to show you how to figure out where that network starts, where it ends, and then where the next network will pick up. And then also covering how to find the exact number of hosts in a network or the exact number of networks. So I'm just going to jump right into it. I'm going to start just by giving examples. So I'm going to come up with some scenarios, and I'm going to show you how to do this in the easiest way possible, and of course, explaining along the way. So with that being said, let's start with, well, first of all, I guess let's start with mentioning the fact that in binary, which you're going to have to convert IP addresses into binary. Now, don't let that scare you, because you're going to find out it's going to be the easiest thing that you've ever done once you get the hang of it. And binary works in powers of 2. So if you look at things like maybe the RAM amount in an older computer. Remember back when it was like 128 megabytes, 256, powers of 2, and you're going to find out that IP addresses work the same way as far as converting them into binary and then figuring things out as far as the number of networks, number of hosts, so on and so forth. So with that being said, let's make a chart at the top of the screen. So when you first start subnetting, this is going to be the first thing that you probably want to do. This is going to help you a lot. And this is the first thing that I do, is making this chart wherever, on the top of your notepad, on your computer, wherever it is that you are working. Sometimes I'll bust open a notepad document on my computer and just type it out on the top so it can help me along. So the chart looks like this. So 128, and then we're going to half this all the way down to 0. So 128, 64, 32, 16, 8, 4, 2, 1. Did I say 0? I meant we're going to half it all the way down to 1. So once you make this chart, you are ready to start subnetting. So let's come up with a network. And for the sake of simplicity, we're going to start with Class C networks. The reason for that is because it's a little bit more mind-bending when you deal with something that is larger. So say I started with the /16, which would mean that the first 2 octets would define the network, the last 2 would define the host. Just because you have another octet's worth of room to mess around with as far as like the network range. I think if we start with the Class C, then just manipulating that last octet, because a Class C, classfully is a /24. So that would be a 255.255.255.0 subnet mask, meaning, so say if the network was 192.168 1.0/24, that would mean that the 192, the 168, and the 1 would define the network. That last octet, whatever was in there, would define the host. So if we were to subnet a class C, which is what we're going to do, we only have to mess around in that fourth octet. So once you gain an understanding of this, then you can move on to subnetting larger networks like a class A or a class B. So with that being said, let's go with 192. And really quick, I just wanted to apologize for my writing. It's probably going to get messy. And if that's going to be an issue, I'm sorry, and you might want to find another video if that's the case. But I'm working on a Surface Go right now, so that way I can use this pen, and I'm not very accustomed to it at this point. So I'm going to try to do the best that I can and make this as legible as possible. So 192.168.1.0/24. So this will be our network. And just for reference purposes, I meant to put that in green. So the subnet mask will be 255.255.255.0. So that /24, that is basically, you're just in that CIDR notation is counting the bits in the subnet mask. That's all that is. It's very easy. So if we were to look up at our chart, the 128, 64, 32, so on and so forth, the 255 would indicate that all of those bits would be on. If we converted this 255 into binary, all of these added together would equal 255. So essentially, when you see a 255, that's 8 bits. So we look at the subnet mask and we see 8 bits, 8 bits, another 8 bits, and then we have a 0. So 8 plus 8 plus 8 is 24, so that would be a /24. So if there's any confusion surrounding the CIDR notation, it's just counting the bits, and that's all it is, nothing more. So, hold on one second while I take a sip of my coffee. Got to try to stay energized through this. So, all right. So looking at this network, this class C, say that we want to, say that we need a network, we need multiple networks that contain at least 20 hosts. I'm just pulling this off the top of my head. So first, you need to realize that a lot of times you're never going to get exactly what it is that you are seeking after. So say in this 20 hosts, we're probably not going to end up with a network with exactly 20. It's either going to be a little bit under or a little bit over. And the reason for that is it's just the way binary works, the powers of 2. And essentially, in a situation where you need a specific number of networks or hosts, you're always going to be a little bit over. Obviously, because if you go under, then that's not going to be enough. So it's better to have a little extra. Now, once in a while, you might hit it right on the dot. So say you needed, say, 32 networks. That would actually even out when you did the math, and you would have that. So if you needed, say, 35 networks, the next jump would probably be 64. So that's just the way it's going to work. So anyways, in this example, we're going to be looking to have multiple networks of 20 hosts. So write that over here. 20 hosts. Okay. Now, step 1 is converting to binary. So we take the number of hosts and we convert that to binary. So all you're doing is you're counting up here to see what would equal 20. So 1, 2, that's 3, 4, so we got 7, we have 8, so now we have, let's see, 12, 13, 14, 15. Actually, you know what? I'm not going to lie. I haven't done this in a little while, so I might have a little blip once in a while. We don't want to go from the right to left. We want to go from the left to right, because then we're going to end up with a situation where we're not going to be able to convert that to 20 because it's going to be over. So once I added that, 16. So, all right, so let's start from left to right. I apologize about that. So we see 128 is too big. 64 is too big. 32 is too big. Now 16, check. Now if we do 16 plus 8, that's going to be 24, so we don't want that. But hey, look at this. 4, if we do 16 plus 4, we get 20 exactly. So then we don't need the 2, and we don't need the 1. So if we look at the ones that we've checked off, we see that we got 16 plus 4, and essentially what we're looking for in this scenario is just the number of bits that it's going to take. So the number of bits that we're going to have to reserve in this octet in order to have our 20 hosts, or as close as possible. So I'm going to draw a line right here. We see 1, 2, 3, 4, 5. So it looks like we're going to need 5 bits. Now, even though we didn't use the 8, we didn't use the 2, we didn't use the 1, that doesn't matter, because it's all about the number of bits that we need to reserve for this. So since it started right here with the 16, we know that we need at least 5 bits. So 5 bits for... Oh, and this computer has a little bit of an issue where this side of the screen wants to be a little bit wonky. So let's write it down here. 5 bits for hosts. Okay, so now we know that we need 5 bits for the host portion. So the next step is to convert the subnet mask into binary, which we already know because I just mentioned it, that the 255s are going to be all ones. Because if we did 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, that would be 255. But just for the sake of example, I'm going to write it out anyways. So we'll go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's our 255, 255, 255. And now, this is where these 5 bits for the hosts to make our networks with 20 hosts each comes into play. So host bits will be the rightmost bits, and the network bits will be on the leftmost. As you can see, if this was a if this up here, this 192.168.1.0 is a /16 natively, meaning the 192 and the 168 define the network, and we subnetted it to bring it up to a /24, then you see that the leftmost we would fill in over here to define the network portion. So, and you're going to see that in the next video when we work this out based on the number of networks. You have to pay attention as to where you add your ones in your zero. So if we need 5 bits for the hosts, then we need to make sure that. Actually, it will be in this video where we figured that out, because what we'll do is so 8 bits per octet, so 5 and then 6, 7, 8. That means we'll have to pad this with 1s to make sure we have our 5. So I guess that's what I'm trying to say, is that the host bit, so if we need 5 for host, so let me see if I can squeeze it in. If I write from right to left, so I can give you an example. So we go 1, 2, 3, 4, 5, like so. We need to have the full 8 bits, so we would do that by, and this is what subnetting is all about. We're actually shrinking this network down. We're giving it a longer prefix, which is shrinking it down and essentially turning it into a /27. Because if we add these together, 8 plus 8 plus 8 is 24, and then 25, 26, 27. And that's why I was mentioning that about the network bits being on the left, host bits being on the right, because if we made a mistake and say we added those 5 bits and went 1, 2, 3, 4, 5, and then we're like, okay, we have our 5 bits, and then okay, so 5, 6, 7, 8. It doesn't work that way. So, or if you just padded it in with more zeros, then we would be right back where we started with the /24. So, anyways, so converting that 20 into binary, figuring out that we need 5 bits reserved for the hosts, meaning that we need to pad this with 3 network bits. So 1, 2, 3, 4, 5, and we have our 8 bits now, including our 5 host bits. We know that now we have shrunk this down to a /27 network. So now we have 192.168.1.0/27. New subnet mask is going to be 255, 255, 255 dot, and then we look at these, and the way we figured this out is essentially adding from left to right up here using our chart. So we go 128 plus 64 equals 192. 192 plus 32 equals 224, I believe. So that would leave us with a 255, 255, 255, 224. So our first network is 192.168.1.0, the /27 mask, subnet mask of 255, 255, 255, 224. Now, like I mentioned about not having the exact number that you're intending to get, so we wanted 20. How do we figure out exactly how many hosts this network is actually going to give us? So the way we do that is we look at the host bits, so 5, and we go 2 to the power of host bits. So if we go 2 to the 5th power, I'm going to have to use my calculator. It's a little bit early still, so I'm not quite with it like I should be. We know 2 to the 5th equals 32. So that means we'll have 32 IP addresses available on the /27 network, but one is going to be the network ID, one is going to be the broadcast. Just like in a classful /24, the .0 here would be the network, and then the .255 at the end would be the broadcast. Once we subnet, we shrink it down, then we need to figure out which one is going to be the network ID and which one is going to be the broadcast. So this 2 to the 5th power, to figure out how many hosts we're able to fit, usable hosts, we do 2 to the 5th, so 2 to the power of network bits, 32, and then minus 2 for that network ID in the broadcast, which equals 30. So we'll actually get 30 hosts out of this network, which is fine because it gives us a little bit of growing room. Now, what if we only reserved 4 host bits? Because you're thinking, well, I'm trying to get this as close as possible, and that's 10 more, and I know that network's not going to grow. So, what if we just, what if we deducted 1 more bit, took that away from the hosts to try to shrink it down a little bit more, and we went with 4. Well, if you were to do that, let's do this over here. So if we were to go 2 to the 4th, that would actually equal 16. And then minus 2 for your network ID and broadcast, you'd be left with only 14. So you would have 6 less, and that's just the way that it works. So if you needed a network with 20 hosts, then you're going to end up with a network with 30, and then you have that 10 extra for that growing room. And then finding the number of networks is the same, except we go 2 to the power of network bits. Up here, so that would be 3. So 2 to the 3rd power, and 2 to the 3rd power equals 8. So that means we would have 8 networks of 30 hosts each. And that is how you do it. So just to recap really quick, and then after that I'm going to show you how to find the increment, so when the next network starts. You take the number, so 20 hosts, you convert that to binary. Once you convert it to binary, you figure out how many bits you need to reserve. Remember, network bits are on the left, host bits are on the right. So if it's networks you're after, then you add those to the left. If it's hosts you're after, then you add those to the right and pad it with network bits. So pad it with 1s so you get the appropriate number of hosts. Once you do that, then you can figure out what your subnet mask is. So taking the number of network bits, once again, and adding them up using the chart. So again, in this case, it comes out to a /27. And then figuring out how many actual usable hosts you're going to have, and then if you want to figure out how many networks. So it's all about converting that number to binary and then modifying that subnet mask appropriately to reflect the new network that you just created. So the last thing in this video is essentially just figuring out, all right, well, that's cool. I get it. I hope you guys get it. If you, and you might not the first time around. And if you don't, I urge you to rewatch the video, do a couple practice questions, and you can check your work by just Google a subnet calculator, and there's a really good site where you can just type in the network and the subnet mask, and it's going to show you the network range, the number of hosts, number of networks, network ID, broadcast address, so you can kind of check your answers and know if you're right or not. So, anyways, moving on. Let's see if I can just move this up. So actually, I do need I need this chart. Can I move it down? No. All right, so I'm going to move this up a little bit, and then I'm going to rewrite that chart. I have real limited screen real estate here on this thing. It's like a 10-inch screen. So this is 128, 64, 32, 16, 8, 4, 2, 1. Okay, so we're finding the increment. So we need to know, okay, well, the network is now 192.168.1.0/27. Okay, 30 hosts, that's great. 8 networks, but where does the next network start? So we figured that out by looking at let me drag that down a little bit more. We find the increment by looking at this once again. So breaking that new subnet mask, that 20/27 we just made, breaking that down into binary, and we see that that would be 3 additional bits. So just like we did to figure out this new number right here in decimal, and we'll look on our chart and see 3. So we see 128, 64, 32. Where we stop is our increment. So our increment is 32 in this scenario. So that means that we have 0 would be the start of our first network, 32, 64, so on and so forth. So our ranges would be subtracting 1 from the next network. So 0 through 31, 32 through 63, and then, let's see, 64. I'm really rusty on my math today, so 64, 96. So the next one would be 64 to 95. So essentially, I'm sure it's clear to you guys, but just to clarify, so that would mean 192.168.1.0, 192.168.1.32, 192.168.1.64, through 31, through 63, through 95. So and then you would just keep going until you reach the end of that broader subnet. So when you eventually get to 255. So the 192.168.1.0 would be network ID of the first network. 192.168.1.32 would be the network ID of the second network. 192.168.1.64 would be the network ID of the third network, and so on and so forth. Now, to find the usable host range, because we do have that network ID, and then this would actually define the broadcast address for all of these, you would just go, you would add 1. So 0 is the network ID, so 1 would be the first usable address, and then 31 is the broadcast, so subtract 1, so 30 would be the last usable address. So essentially, I'm just saying that we would have 192 for usable addresses that we can assign our hosts. We would have 192.168.1.1 through 30, 192.168.1.33 through 62, 192.168.1.65 through 94, and so on and so forth. And that's pretty much it. So this is the first lesson in subnetting. I really hope that you learned something. If you have any questions, you can reach out to me either by leaving a comment in the comment section below. You can reach me via email at rob@rmtechcentral.com, or you can visit my website, rmtechcentral.com, and use the contact form. I'd be more than happy to answer any questions if you're struggling with the concept. And of course, if that is the case, don't forget to just try to rewatch the video and really try to get it to sink in. It's a little bit to grasp, but as long as you remember the steps, as long as you remember chart, start at 128, all the way, half it all the way down to 1. Take the number of hosts or networks, convert that into binary, fill in that octet for that subnet mask appropriately, and then go from there. So I really hope this was helpful. Again, reach out with any questions. I'd be more than happy to help, and I will see you in the next video. Thanks for watching.